Good morning, everyone. Welcome to the final presentation of the SimBot Dataset Collection Project. I'm Bharani, and this is Lini, and both of us have been working together. Before we begin, we'll take you through about what was the vision for this project and why we chose this problem statement. So task-driven embodied agents are artificial agents that move through the real world and sort of complete tasks by affecting the physical environments just as we humans do. And they do so by learning or mapping from natural language instructions and egocentric vision to sequences of actions. However, existing benchmarks and models for building such embodied agents rely heavily on text as a modality to learn, as well as they're not capable of going directly from hearing to doing. And we know human intelligence simultaneously processes data from multiple modalities, including natural language, be it audio, text, as well as egocentric vision. And there's been a lot of improvements in machine learning models in every individual modality, be it text or speech. And there's been a growing interest in building multimodal embodied agents. And while the current navigation models for navigation tasks sort of very tightly integrate language and vision, but today's embodied agents are still deaf in terms of being able to go directly from hearing to doing what we're telling them to do. So with that being the vision, we'd first like to take you through a few of the tasks that are present in this sort of a domain. The first one being spoken captions. It is an audio to image retrieval task, wherein here is an example of how an example from the task looks like.
A view of a very tall mountain or volcano with snow on the top, with a lush green field with red flowers in it.
So the whole idea here in this task is that the agent sort of learns to align parts of the audio to the corresponding parts in the image. So when they said a lush green sort of patch of green with a forest or a volcano, so those parts got highlighted. So this is an intersection, you could say, of audio and language, which is spoken captions. The second is sound spaces. Sound spaces is an audio navigation task wherein there is a sound that is emanating from a particular target somewhere in the environment, and the agent needs to navigate to that position, which is the goal position, but without any access to a map of the environment. So it needs to use its sensory inputs, be it vision or audio. So for example, here is a so the fire alarm is actually going off, but there's also like a piano playing. So the task is for the agent to navigate to the fire alarm while having background noises of the piano. So another benchmark is Alfred. Alfred is a benchmark that helps in mapping natural language instructions to a sequence of actions, especially for household tasks. So this is a combination of vision and language. So for an example here, you see a robot sort of performing, switching on a light and looking at an object under the light. And these are sort of the tasks that we're looking at in this entire landscape. And how we're going to be contributing to this landscape is that we want a model, or we want to enable the community to build models that can go directly from audio to action and do not have a bottleneck of having text as an intermediate modality. So this is an example, in fact, from the data that we've collected.
Pick up the scrub sponge from the white cell and wash it in the sink. Then put it to the lowest rank of the white cell.
So essentially what we want the agents who learn from our data set to be able to do is, given egocentric vision and a speech audio input, they should be able to understand what is being said and sort of do all the tasks. So you see on the right that it was mentioning pick up the scrub sponge from the white shelf and wash it and then place it back. So this is an example from the existing Alfred dataset. So this is sort of to show you how we perceive the newer version of Alfred dataset would be, wherein we can train models that can go directly, given audio and egocentric vision, to doing the action. And to sort of culminate everything I spoke about, there are challenges to building embodied agents that go from audio to action. The first being there is no existing benchmark that sort of has all of these components together, including human speech and not synthesized speech. The second is modeling is hard, that because you require learning both jointly over vision and audio, which are both continuous, noisy, unsegmented, and audio introduces a wide number of non-lexical variabilities, which could be like accent, etc. And it is challenging to collect embodied speech data. So through this project, we're going to be collecting speech annotations for Alfred by crowdsourcing data to create a benchmark that can be used to train models that can power robots to achieve audiovisual grounding, similar to how we humans interact in the real world. And so this is sort of like a representation of what we want to do. Given an audio signal, we want to sort of eliminate that middle gap of converting it to text, and we just want to go directly from speech to action. And an extension of this could be with both modalities, text and audio, can we sort of extract the meaning and go to the action space? So we propose that in order to be able to do this, an embodied agent should acquire compositional understanding of instructions to understand the subtasks that are involved in a task. They should learn to choose an action from a wide range of actions that are available and execute them for continuous longer horizons. And they should be able to locate objects in a fine-grained manner to be able to interact with them. And in order to collect data, we will be building a data collection platform through which we'll be able to qualify participants to ensure they understand and they give us good quality data. We'll ensure that we're able to record whatever they say about describing the task that's presented to them. And while they do so, we'll be capturing any logs about all the information we can to make sure that this data set is complete by itself. And yeah, about the hypothesis. So the hypothesis we make is that adding this dimension to Alfred will bring us closer to how humans interact in the real world. And this will encourage the community to leverage the power of modalities that other than text have to offer, especially for embodied instruction following tasks, and enable the currently deaf embodied agents to learn to navigate by both hearing and seeing. And we believe the audio data that we collect will consist of references to physical properties of the environment and the different varied level of instructions, as well as a varied amount of vocabulary, because we'll be collecting it like from by crowdsourcing. So the larger number of people we collect more information from to make the embodied agent as robust as possible. And yeah, Linny will take you through a few slides now.
Yeah, so now we talk about the development goals for the fall semester. So actually in spring semester, we have a little bit of different projects. Wanted to build a data collection platform that involves pairing up to users online and have them work on collaborative tasks through AI simulator. And then we'll collect their dialogues through audio streaming. But after doing some pilot studies, we realized that this plan involved too much engineering work, and it also have a high demand of scalability. So we considered it infeasible to complete within one semester. So for this semester, we instead of like building a new data set, we changed the scope of the project to adding a new dimension to an existing data set, which is to collect speech annotations for Alfred. So here's a timeline for the fall semester. So after creating our new fall plan, we first prototyped the data collection interface. And we spent some time building and iterating on the qualification and main data collection interface design. Right now, we are running and analyzing the actual data collection. So in terms of the intended users of the data sets and the platform, for the researchers, they can use the visual and audio data from the data set to as the input to their model and produce a sequence of low-level actions as their output. And they can also use the data collection platform to speed up their research in collecting multimodal data. For the developers, they can use the data set to develop robots that can understand and execute human instructions. And they can these models can help people in daily lives, for example, household tasks. And for the crowd workers, they are mainly the user for our data collection interface, and they help us collect the data to enhance Alfred. So here are 4 major features that we introduced in our data collection platform. So first, before we move the participants onto the main data collection task, we first qualify them. And this is to make sure that our collected data is of good quality. We also capture the logs of the experiments throughout the task to make better analysis of the data. So we also able to capture the audio inputs from the crowd workers. They describe the scenes in the Alfred datasets. And we also offer them an option to listen to their audio and re-record if they are unsatisfied with their recording. And the crowd workers might need to take some notes when they are preparing to record the audio. So we also save those notes, and we also capture any feedback they have upon submitting the text. So there are some more specific system functionality for the data sets and the platform. So for the data sets, so every audio that we collected should be a clear, coherent, and natural audio description of the Alfred videos. And the total number of data points that we have should be large enough for training the models. And very importantly, each instance from the Alfred dataset should be annotated by at least 3 participants. And for the data collection platform, we utilize a crowdsourcing marketplace to recruit crowd workers to help us complete the tasks. And we also include all of the features that we just talked about. And for the crowd workers, they are instructed to interact with this user-friendly interface, and they're also informed the expected duration and rewards before completing the task. And here are some non-functional requirements of the data collection platform. It should be available throughout the data collection process, and every component should be successful communicating with each other. And the audio quality, the logging information, and also the text inputs should be of good quality when they're captured. And we also preserve the user information for the crowd workers. And it should also allow easy testing, including unit testing and integration testing. And the platform should allow us to collect samples in batches and allow multi-participants to work on tasks simultaneously. So it should also be easily used by the crowd workers, and should allow researchers and developers to track the experiment flow. So here are the tools that we use in our project. So the source of our data is the Alfred benchmark, as the around 8,000 Alfred videos that we are used to collect the speech annotations. And we use Amazon Mechanical Turk as the crowdsourcing marketplace. We store all of the Alfred videos on AWS S3 buckets and store some of our exemplary audios on S3 too. But all of the data that we collect from the crowd workers are actually stored on the instance. And we use HTML, JavaScript, Bootstrap to design our front-end interface. And for the main data collection, task, because we're collecting audio data, so we are relying on a third-party toolkits, which is an open repository, open source repo called SpeakTool. So this is written to collect audio data from mTurkers. And this toolkit is based on Python with using Flask as the web framework. And they also use Google Speech Recognition API to transcribe the audio to text. And Bottle3 is used to communicate with mTurk on the backend. And we use EC2 instance to host the server, and we use Nginx to load balance. So here are some design considerations. So we have some assumptions for the participants in our task. They should be living in the North America and have good cognitive ability to understand and execute what we have in the instructions. And the system environment includes qualification task and the main data collection task, like we just mentioned. And we employ a modular approach to design our data collection platform to include all the features that we desire. So in terms of the resource requirements, there are 8,055 Alfred videos, and all of them should be annotated either by the end of the project or in future work. And here are some configurations for the cloud server. And the AWS account should also be Amazon mTurk enabled in order for our backend to communicate with the mTurk. And the crowd workers also have we also have some requirements for the crowd workers, including their browser and microphone and speaker. So here's an overview of our design. So like amateur crowd workers should first go through a qualification task. So hits here as a terminology for a virtual task that a crowd worker can work on, submitting answer and collect the reward. Once they are approved, they'll be moved on to the main data collection task. So we'll go through this slide in more detail in the following slides. So we will first look at the workflow for the crowd worker. So we first have some basic qualifications for the crowd workers in terms of their location and experience level. So their location should be in either US or Canada, and the experience level are represented by the number of completed hits and their acceptance rate for the completed hits. So only those crowd workers that are eligible, that meet these basic qualifications are eligible for participating in the call hits. So in the call hits, we have some instructions, requirements, and examples to help them better understand what we are looking for in the task. And then they are given five like series of audio, outfit video, and audio pair. And they need to check if every audio description has all of the properties that we desire from the audio. And they can also submit some feedback about this hits. And after they're done with the call hits, once their answer meets some threshold, let's say 80% accuracy, they will be moved on to the main hits. We also have some instructions and requirements and examples to help them understand what we are looking for in their audio description. And then they will be a recorder and for outfit video for them to record themselves describing the outfit video. So here's a workflow for the researcher. So for the call hits, it will be directly hosted on the through mTurk requester because it doesn't involve any multimodal data, so it's relatively easy to do, really easy to host. And for the main hit, because we need to collect the audio descriptions from the crowd workers, we host it through the Speak tool, which is like the third-party API. And so the researcher and developer will also run the main hits through in batches. So each batch will contain around 100 videos. And after we're done with each batch, the researchers would run data analysis and iterate on the design of the main hits. So here's an example for the examples that we have in the call hit. So we can see that the 4 properties that we are looking for in the speech annotations are, like, first mentions all the necessary actions in audio description, and if the audio description mentions all objects correctly, and maintain order of subtext. And the audio should also be clear, concise, and natural. And here's some explanation for why this example is a good one. And we also have an example of a bad example. So some of the properties are not satisfied. So here's the actual call hit text. So like the crowd workers should check each of these properties and whether they're contained in the audio description. So here's the example in the main hits. So this is quite similar to what we have for the call hits. So here's the recorder in the main hits. So there will be a offer video on the left-hand side, and there's a text area for them to take some notes to help them remember the actions, objects in the video, and also remember the sequence of actions. So the 4 different videos will be presented one at a time. And when the crowd worker is ready, they will contain the green record button at the bottom. And this is what it will look like when they are recording, and they will click on the stop button to stop the recording. And recording stopped, we have a playback audio for them to listen to their audio, and they can click either submit or discard. If they click on submit, they will move on to the next video, and if they click on discard, they will continue to work on the same video. So here's the data that we collect from the qual kit. So the second column here are the 4 properties that we ask the crowd workers to check. So this is like either true or false, whether they think that this property is contained in the video, in the audio. And here are the data that we collect from the main hits. So this like the text index here is the index number for the sequence of videos in the text. And these 4 are the video ID, the recording, the transcription of the audio, and also the notes that the crowd workers written. So here's the test design. So for the data set, we first run several pilot studies on the call and main hits to iterate on design and make modifications if there are any ambiguities. And we will also build automatic checks to filter data for the training and development sets. For the test set, we will manually inspect and clean it. And data collection platform, we will do some experiments to ensure that the key non-functional requirements are satisfied. And for deployment, both the data set and the data collection platform will be open sourced. And in terms of the risk and challenges, like the faithfulness of participants, including their also their experience level, will pose a risk to the quality of data collected. And we are also constrained by the costs and complexities for building the platform and also recruiting the crowd workers. Yeah, Barani will talk about the results.
To quickly go over the results. So we ran a pilot amongst our peers with a very small sample size because we got only 11 responses. But we the whole idea here was to understand how long were they taking to do the task, and were the instructions clear to them? Was there something that we needed to reiterate on? So these are sort of like a few numbers about almost on average, they took around 20 minutes to complete the qualification hit, and the maximum was around 48. And when we went back to figure out why that happened, they actually just left the interface. Like after completing it, they did not submit, they just left it on. So the time sort of ran over. And apart from that, we see that most of them sort of got like an accuracy of 70%. There was one person who got around 30-40 who was probably not interested in doing what we sent out. And yeah, this is sort of this is showing how every property for every question. So was the first audio clear, second audio clear, and so on, and what was the accuracy from the responses we received. And we saw that there were 2 specific instances where we saw very low accuracy, where we expected them to go with one option and they actually went with the opposite. And the last few responses are out of scope for right now, so we'll not be focusing on them. So these 2 options that were highlighted, actually what happened is we wanted them to identify the objects correctly, but there were 2 sort of instances of the same object, and they did not, if there were 2 pencils, there was one on the right and one on the left. So there was some ambiguity about whether we should be very specific about picking the pencil on the right and mentioning that in the audio. So which is why there was some confusion, and we've updated the instructions to say that we just want the object type to be recognized correctly. And also there was a lot of audio that seemed unnatural, in the sense there was detailed explanation saying go left, go right, go down, and things like that, which is not natural for somebody to, if you had to ask a robot to say go pick up something, for me you wouldn't say turn left, go forward 5 steps, and so on, which is not what we want, at least in this benchmark. And there was also feedback that the example audios we had were very long to sort of watch. And so what we did is, instead of having a good and a bad example for 2 different instances, we just created a good and a bad example for one instance, so that it makes it easy for them to compare as to what is expected and what is not. And there was also some feedback that the example audios we had were not recorded by native English speakers, who are actually the people who will be giving us the data. So we sort of replaced the example audios that we synthetically synthesized with the data that we got from the pilot runs that we ran. And yeah, this is about the pilot studies that we ran for the main hit. So these are studies on MTurk itself. So we got data from people, and the main hit takes lesser time to complete because they just have to record annotations for 4 videos at once. And the first time there is some information to get through in terms of instructions, but from the second time onwards, it makes it faster. We had around 33 unique participants who annotated over 90 videos for us. And from amongst the 33 unique participants for the 90 videos, doing an automatic like ASR transcription of the audios we received, we saw vocabulary size of 500, which is not too big. But we believe when we sort of scale it to more people doing it, we should have a higher amount of variety coming in. And we also see that the audio annotation length is varying from 14 seconds all the way to 48 seconds. And when we went ahead to see why was there such a long gap, we see that there are people who went way too detailed, probably because they actually do similar tasks like this on a crowdsourced platform like MTurk. And they've done tasks like this before where they had to give like precise instructions saying, go here, take left, go right. And this is not what we need in this task. So we sort of went back to reiterate on our interface to make it very clear about what we are trying to do. And on the left, the graph you see is again a histogram of how long people took to complete. We see a majority of them are under 15 minutes. And the graph on the right is, we just wanted to understand if the video we show them, if the length of the video increases, does the length of the audio transcription they give, like the annotation, does that increase? We see that it does not increase significantly, which is right, because there might just be, if there are more actions that are happening, it will increase with it. But overall, we do expect the audio duration to be under 20 seconds. And here are a few examples of the data we received. So you can see the longest transcript. So this is sort of very unnatural in terms of what we want. And they gave us feedback about why they did this as well. And we also found that there were a lot of words that were used interchangeably, like commode, toilet, sofa, couch, and so on, which is good because we do want variation. When the embodied agents learn from this data set, they sort of get access to a lot of variation. However, there was also some incorrect object identification, such as potato was identified as avocado and tomato as an apple. And we believe this happens because when you see the video, even we were confused about what the object type is, but we believe with doing this over and over, I think it's okay to have incorrect examples because we can't have precise examples all the time, but these have been very low in number. And on the right, the word cloud that you see is sort of just about what are the words that were used in the ASR transcripts that we got. So we see pick, put, place, take, and so on. And in fact, the data that we got did confirm to our hypothesis. We did find references to physical properties of the environment, object references, high-level goals, low-level goals, and so on. And however, there were a few instances where we saw transcripts such as this, like turn left and turn right, look down, turn left, and so on. We also had incorrect object identifications and unnatural descriptions with too much emphasis on detail. And this is sort of the feedback we received from the crowd workers. They could be categorized into these 5 types. The first being, initially, they were not able to submit. Our servers were not able to handle the load. They felt our instructions were unclear about how much detail, like were they supposed to be concise or be more expansive in terms of what they say. They wanted us to allow them to re-record because they felt like they did something wrong and they wanted a chance to re-record. Some of them said they wanted us to enable playback of recording. They wanted to listen to what they just mentioned. And there were some responses that said they were underpaid. And we sort of acknowledged this because we told them this is a pilot and we will be increasing the remuneration in the future iterations. And in order to sort of fix these, we updated the Nginx configurations. We sort of did some testing to identify the right amount of buffer sizes because we are dealing with audio that's coming in. And we enhanced the instruction prompts. We updated the interface to re-record and allow playback. And we've now increased the remuneration per hit for the crowd workers. And as we're coming towards the end, we believe we've sort of, the whole idea we had for this project was to set up the groundwork so that we're ready to go into the large scale data collection. And we want to conduct one batch of data collection so that we now have iterated over 3 times on our design. We want to collect one batch before we submit our final report. And then the research goals for future are definitely carry out the entire annotation and start developing baseline models to show why the data set we propose is good and why the existing baselines will not work on our data set. And yeah, before we end, a few reflections. Mainly have to deal with that we had a particular scope initially, but we were not able to sort of complete it. We had a few tasks planned for the summer, but we weren't able to finish it. And we believe from now on, whenever we work on something, if we have another full-time commitment, we should not be taking up something that might later on sort of result in moving away from it. And we should estimate the feasibility by looking at both the team size as well as the timeline. And one thing is that engineering and infrastructure related work is really tricky. So we should always consider some buffer time to familiarize and implement them. And everything might seem well until you actually start getting real data from people. So be ready to sort of reiterate multiple times on your interface. Because we went in thinking everything we did was super clear, like we were good to go, but we actually had 3 rounds of doing this again to reach where we are. And yeah, those are a few reflections and learnings. And thank you.
Great job, guys. Really enjoyed the presentation. So I guess I have a couple of questions. So when and how did you realize that the original plan for data collection was going to be infeasible? And I guess the sort of devil's advocate question would be, why didn't you know that before you started? So did you learn something along the way that made you realize you'd have to change direction?
Yeah, I think initially during the spring, most of our time went in sort of understanding the domain and sort of listing down what are the tasks we have. And we did end on a note that we need to get things done in the summer, but we both had full-time internships and we did not end up putting up the effort. Had we put in, I think we would have continued with the original scope because we were equally excited on working on that. But that had a lot of moving parts because that needed 2 people to work together. We had to record both of them speaking, pair them up together, and be able to scale that sort of a platform. We started realizing when it was August that it's not going to be possible, but we also wanted to stay in the same domain, like of data collection. And we then thought about what different avenues could be explored. And turns out all of us agreed that instead of creating something from scratch, we could enhance something that's existing. And after doing a lot of reading up, I think we felt like this was a potential because there were tools that were existing that we could sort of pick up and put in together. Had we not had Speak Tool, I think it would have taken us even more effort to get this done. So it was really nice that we could take in things that were being built by the community to sort of enhance this. And yeah, because one thing I'd like to point out is that MTurk does not allow us to collect audio samples out of the box. So because of which a lot of studies have been sort of implementing their own tools and not sort of open sourcing it. And Linny sort of found this recent paper publication and it was a great find for us. And I guess it took us like the first few weeks of August to realize what we had planned is not feasible, but yeah.
You guys did a great job, so don't fret about that. You actually, the more twists and turns your path has in your capstone, the more you actually learn, because that's how you accumulate experience, for projects. I would also argue that by doing something very concrete using the actual tools available and literally scaling it so it really works is the right first step for anybody that wants to get into crowdsourcing, even if eventually they want to do something that's more sophisticated, which is great. Let's see. And of course, we don't expect you to work over the summer, so that was fine. So don't feel like you needed to do 3 semesters worth of work. I'll also say that you guys really discovered and explained all of the usual issues with trying to do something like this. So I feel really confident that you've learned it and you're kind of experts now. And yeah, if you could get the 100 videos transcribed with at least 3 people by the end. That would be nice, because then you could say that you actually did acquire a reasonable data set after all of these changes that you have to go through. You did a nice job of talking about qualification, and then what the sort of actual error modes were for the people that passed through qualification. Those are things I was really interested in. I really enjoyed when you showed the actual interface, because I was really thinking about this. How the heck am I going to do this task in real time while I'm watching the video? Because I don't really know what's going on until we're several seconds in the video. So I thought the little scratch pad and the capability of being able to re-record was really smart. And I can imagine that some people would just try to speak their way through the first time, discard the video, and then do it again real quickly. And then other people would type and take time, and then render it once. So were there different styles among how the Turkers did the task? Can you tell from the log data? So were there some people that recorded and discarded a lot of videos, whereas other people only recorded once every time?
We're actually adding the playback function and after the pilot, so we haven't tested it yet.
Once you get the new data set,
yeah.
start gathering, things like that.
Yeah.
The reason why I'm interested in that is that eventually, you want to have a system that can literally do real-time captioning while it's walking around, right, with a camera, and being able to learn from where humans make mistakes when they're doing that could be a really interesting source of data. So are you keeping the discarded recordings, or are you throwing them away?
For ease of implementation, we're starting it, but we feel like it's so recent to we have the technical values. For now, because we were under our timeline, but I think we will go ahead and keep it to understand.
You could ask really interesting questions like, which are the things that are hardest for people to understand? Well, they're probably the ones where they have to record more than one. And then you could go back and look at whether or not you could find the sources of difficulty or ambiguity in the feature space, and that could be helpful for training a robot, captioning in the future. Okay. You mentioned that you were going to do manual cleaning of the test set. How much time did that take, and is that going to be feasible, for 100 videos? What's actually involved in doing that cleaning, and why do you need to do that?
This was more in terms of when we released the data set, because we would have like leaderboards we were looking at the longer term. So in that case, we would want to ensure that the test set does not have any noisy samples. There are, as of now, for the pilot, we went through every single audio. We sat and listened to it to understand if what they're saying, and because we were using Google's cloud speech API, some of the transcripts were inaudible, and when we went back to see were they actually inaudible, we saw that they were all empty voice recordings. So we did find that we're going to be adding some automatic checks to say that there should be minimum number of these many words in the transcript. Only then we sort of allow them to move forward. But right now the cleaning we did was to go through every audio recording, and I think talking to our advisor, I think the final test set that we release will have gone through a lot of scrutiny, but I think most of the dev in the training sets would undergo like automatic evaluations as extensive as possible.
We're going to have to get out of the room.
Okay.
Two quick thoughts. One is that when you express the time taken by the human to do the task, where there's a root video they're looking at, video researchers usually express that in multipliers of the real time. So if it's a 1 minute video and then it takes me 10 minutes to do it, that's a 10 times factor. That would be more interesting than just knowing the length, because it kind of depends on the length of the original video. Then the last thought would be that since one of your goals was to produce a framework that could be used by other researchers, in the future you want to do a habitability test, where you sort of point some researchers at the repo and say, hey, try to use it, and then tell me what happened.